Hello everyone. In this video lecture, we are going to look into the fundamentals of RGB color model. The contents of this video lecture are Introduction, Chromaticity Diagram, and RGB color model. So according to the International Commission on Illumination, the primary colors are red, green, and blue. But no single color can be called as red, green, and blue. For example, for red itself, we have different shades. Green, we have many shades. Similarly, for blue, we have various blue shades. In the visible spectrum, one color is not abruptly changing into another color. Actually, it is smoothly blended to some other colors. One color is smoothly blended to some other colors. Hence, these RGB cannot be sticked on with single wavelength. Here, RGB are only specified by standards, CIE standards. The primary colors cannot produce all the visible colors. The combination of any two primary colors will produce secondary colors, which are magenta, cyan, and yellow. This combination equal part of red and green will produce yellow. Similarly, red and blue is producing magenta, and green and blue are producing cyan. The combination of all these primary colors will produce white color. That is R plus G plus B equals to W, white color. Similarly, the combination of all the secondary colors will produce black. We have three different terminologies. One is brightness. Brightness is chromatic notion of intensity which cannot be measured or quantified. Similarly, hue is dominant color perceived by an observer. It is a dominant wavelength that is in the mixture of different wavelengths. Say for example, if a person perceives an object as red in nature, that is then the hue is red color. Maybe that redness may change for different person to person or object to object, but actually that red is the dominant wavelength coming out of an object, hence it is called hue of that object. Similarly, saturation is relative purity of the amount of white light mixed with hue. All these three terms cannot be measured or quantified. So all these are subjective in nature. So when we call an object red, orange, or blue, we refer its hue. Then chromaticity is the combination of hue and saturation. Hence, therefore, the final color is the chromaticity plus brightness. Meaning, in chromaticity we have hue and saturation. Then combination of hue, saturation, and brightness will produce different colors. So the tri-stimulus values, the three values combining together as RGB is called as tri-stimulus values. So this tri-stimulus value is required to measure or to represent various color shades. This can be done by using trichromatic coefficients X, Y, and Z. Now, this tongue-shaped image can be called as chromaticity diagram. It has different color shades, but on the edges we have three different primary colors: green, blue, and red. So the combination of these three colors produce white color, and we have different shades. But is it possible to get all the color shades by these three primary colors, red, green, and blue? If so, where is the brown in this diagram? Hence, it's not possible to produce all colored shades simply by combining these three primary colors. Hence, chromaticity diagram only shows dominant wavelengths and the saturation, and it is independent of the amount of luminous energy, that is brightness. It has a two-dimensional structure. Then color model. There are a number of color models are available, but here The red, green, blue RGB model is used in color monitors and color video cameras. Cyan, magenta, yellow model is used in color printers. Hue, saturation, intensity model is used for color image manipulation. In this lecture, we cover only RGB model, red, green, blue model. So this is the illustration of red, green, blue model. Here, all these primary colors, red, R, G, B, are aligned in X, Y, and Z axis. So at the origin, all these three color components are 0. Hence, absence of all these colors will produce black color. Then at this point, the three color components are with maximum value. Hence, the equal combination of RGB will produce white shade. So the line connecting black and white will produce different gray shades. So in the horizontal axis is green axis, where the pure green will have only green shade. There is no red component and blue component in green color. Similarly, there is no red component and green component in blue color. And combination of any two primary colors will produce secondary colors. Say for example, cyan is the combination of green and blue. There is no red component in cyan. Similarly, for magenta, it is the combination of red and blue, and we don't have any green component in magenta. Similarly, all these secondary colors are made. Similarly, the same stands for yellow also. So this is the illustration of color cube. So this is the two-dimensional plot of color cube. Here black is at the origin. And the generation of RGB color it is based on having three different planes: red plane, green plane, and blue plane. Combining all these three planes will produce an RGB image or color image. Say for example, in this color cube, this layer is selected. So if it is extracted, we have three different color components. One belongs to red, another belongs to green, another belongs to blue. Here it is along the red axis, hence red is constant shade. Similarly, we have different values for blue and green. So hence, if we combine these three shades, we can get this RGB color image. So if we remove any one shade, say for example, if the red plane is 0 in this image, then it will look like this. So here, if green component is made to 0, it will look like this. Similarly, it is this image is without any blue component, color component. So this is the RGB color model, and this is the fundamental concepts of RGB color model. In this video, we discussed chromaticity diagram and RGB color cube. Thank you.